Welcome to the project demonstration of wireless power transmission along with electrical vehicle charging with voltages display on this LCD. So here we are going to provide the 230 volts here, and after that 24 volts of AC, and particular LC voltage will be converted to DC with help of this diode and capacitor. And after that we are going to generate the 100 kilohertz of frequency, and that was given as main input to this capacitors through this center tapped copper coil. Okay, so this copper coil will be transmitted that 100 kilohertz of frequency with EMF generated around its copper coil. So when we place the another copper coil, so it will act as induced EMF generated, and the voltage will be given as main source voltage to this battery, because we are getting AC signal from this AC voltage signal from this copper coil, and the received voltage will be given to this charging circuitry. So here we can connect the transformer also. With the help of transformer we can charge this battery. So in order to charge this battery, just connect this. This is a way of charging the battery from 230 volts using transformer with a wire connection. Just for demonstration purpose I am showing this like TRR. R nothing but receiver, T nothing but transformer. This is a transformer we need to connect at this shown section. It's very important. I'm repeating, here we need to connect that and just get the power supply. So there will be a light indication on your charging circuitry, so it's indicated as the battery will get fully charged in 6 to 8 hours. So this is a way of charging a battery from the wired connection of the transformer. We'll provide this also. And the next, just connect this receiving coil. So this is a receiving coil output, connect it over here, right? And once the connection was made, so when we switch on the circuitry, as we mentioned, the 100 kilohertz frequency will be generated around this coil, and when we place the copper coil under this EMF generated frequency, like field where that particular receiving coil will be induced, and the generated voltage will be the AC. Same here also, like AC to DC rectifier and filter, and after that we are going to provide the same voltage in DC format to this battery. So once the battery gets charged, so it will be controlled by this for this robot in forward, backward, left direction with help of this box controlling section. And also parallelly we are going to provide the battery voltage as well as the generator voltage to our PIC microcontroller with help of this potential divider circuitry. So here we are going to divide the voltage in 10:1 ratio. Why? Because we are getting 12 volts of DC after this rectification section. So the microcontroller can measure up to 5 volts. So we are going to using the potential divider 10:1. So if we receive the 1 volt, it indicates as a 10 volts. So that's the main purpose of this potential divider circuitry, and the particular voltage will be measured by our PIC microcontroller and display that on LCD, that 16:2 LCD screen. So coming to this microcontroller, we are making use of PIC16F72 microcontroller. So we interface these two input sensors to the A0, A1 pins, because those are analog pins. Then only we can read the analog voltage and converting into the digital, and the particular voltage will be displayed on the LCD, which was connected at B2 to B7. Right. So let us see the demonstration. So just switch on this on. Okay. It's on and off wireless power transmission voltage display. Now the battery voltage is 12.7, but input voltage is 0. And now just connect this. Using this we can control the robots backward, left and right. So now we didn't on this. So when the particular vehicle is coming to this field, so just when we switch on this, right, okay, you can see that slightly is on because it's not in the fully field. So when it is entering into the full field, so we can see the input voltage is 10.1, and when I'm removing that from that field, so the voltage is decreasing. When I placed inside the field, so the generator voltage will be displayed on the LCD screen, and also there will be a light indication. Right, thank you.